Hi guys, welcome all of you to Om Institute, and yes, again finally the ISRO 2025 examination is going to be conducted on 26th of October. Yes, so with respect to it, okay, let's have a practice session. Okay, let's you can also check your final preparation. Few subjects I will be covering. I've given this session as a name of mini mock. Right, because it's not one subject, but a mixture of subjects I will cover, like control systems, signal and systems, microprocessor, and engineering mathematics. Right. So I hope you are ready, and let's get started. And as soon as I present a question, I suggest you can pause the video, you start solving, and as soon as you get your answer, okay, you can match with my answer, and you can also comment your answers in the chat box running. Okay, the open loop gain of a unity feedback system is given to you, omega n square upon s plus 2 omega n. What is the step response of the system? Okay, so let's basically get the idea. Okay, let us basically get the zeta idea here. Okay, how much is going to be zeta? Okay, because if I form the characteristic equation, let me form the characteristic equation here only. The characteristic equation will be 1 plus GSHS, unity open loop feedback. Open like gain is already given, unity feedback is there, equal to 0. So when I simplify, I'll simply get s square plus 2 omega ns plus omega n square, simply suggesting you that zeta is 1. Because this term otherwise in the standard second order characteristic equation should be s square plus 2 zeta omega ns plus 1. Now zeta equal to 1 leads to critically damped response. Critically damped step response. The question is the nature of the step response. A simple question. Okay, so what is the critically damped response? It is there in the option number D. Then it is there in the option number D. A and C are like undamped. Okay, the amplitude of oscillation increasing. This is the magnitude directly increasing. This is undamped. Okay, zeta equal to 0. Okay, and this is for zeta equal to 1. If you want to know, I'll write down. This usually is the waveform for zeta equal to 0. This is zeta negative, -1 to 0, and output increasing without any oscillations happens for zeta less than -1. Okay, right. So our correct answer is option number D. Hope you have got it. Let's go to the next one. The forward path transfer function of a unity feedback system has been given to us. Gs equal to 100 upon s plus 20, s square plus 4s plus 10. For the input of 10.5 ut, the steady state error is how much? For the input of 10.5 ut, the steady state error is going to be how much? Okay, simple question. See, first of all, what is the type of the system? You can clearly identify the type of the system now. Okay, what is there? What is the type of the system? Type, unity feedback is there, so I can define type as the number of poles of GS at origin. Okay, and it is type 0. Because there are no poles at origin. Okay, there is no s power n term separately. Okay, now it is type 0 system, and that is why the question is on steady state error due to step input. Okay, 10.5 ut, steady state error. Okay, for unit step input, is given by 1 upon 1 plus kp for unit step input. Okay, where kp, limit of s tending to 0, gs. Okay, so let me only find the kp first for you. Okay, what is going to be the value for kp, limit of s tending to 0 into gs? Okay, that is 100 upon 20 into 10, s0, s0. Okay, so this is 100 by 200, kp is 1 by 2, finish. Now, for the input of 10.5 ut, okay, applying linearity, steady state error will also be the input multiplied by 10.5, the steady state error. For unit step 1 upon 1 plus kp, here it is going to be 10.5 upon 1 plus kp as the answer. So 10.5 is divided by 1 plus half. 10.5 is divided by 1.3. Yeah, correct. 1.5. Okay. So it is going to be cancelled as how much? 7 times. It is going to be cancelled as the 7 times. Option number C. Option number C is what is the correct answer. Okay. Right. Next, a unity feedback closed loop system has the plant GS equal to 1 by S square and PD controller GCS in the forward path. If GCS equal to TP into 1 plus STD, where TP and TD are positive parameters, which one of the following is not true? Following is not true. Okay, a basic question on the controller, PD controller analysis. Okay, PD control analysis. There is a unity feedback system. I mean, if I want to show you what the question is describing, there is a unity feedback system with the plant transfer function given to you and a PD controller given to you. Okay, with the constant names are TP and TD. TP 1 plus STD. This is the PD controller given to you. Okay, the output of this goes to the plant transfer function given as 1 by s square, output C, connected in unity negative feedback, right? So what is going to be the characteristic equation here? Okay, which of the following is not true? The system is always stable. Okay, TP and TD are positive adjustable parameters. Remember, so what is the characteristic equation? 1 plus GSHS equal to 0. 1 plus GSHS equal to 0. So, no, HS is 1. The overall forward path gain will be 1 by S square into TP 1 plus STD equal to 0. So, simplifying the terms, I will get here a multiply by S square, then plus TP, or first let me write down STD term, STD TP, it will be multiplied, TP multiplied here, plus TP is equal to 0. Now, it is second order, so it is very clear that you don't need Routh-Hurwitz analysis for this. For second order, what do we need? Okay, for second order, what do we need? That if all coefficients are of the same sign, the system is 100% stable. Okay, so this TP and TD are both positive. So, product of TP, DD also positive. The coefficient of S square positive. Okay, the system is stable. Second order, only this much is important. For second order, only this much is important. Okay, so all the coefficients are positive, system is always stable. Okay, we have to find not true statement here. The system may have damped oscillation for unit step system. The system may have damped oscillation for unit step input. Okay, now what is going to be zeta? See, there is the term 2 zeta omega n. Now this is omega n square. So what is omega n? I will write down root TP, and this is given by TD multiplied by TP. Okay, TD multiplied by TP. Okay, zeta will now be given by 1 by 2 and root TP and TP. This will be right side root TP, then divided by, multiplied by TP. TD multiplied by root TP. This is what is going to be the value of zeta. Okay, where TP or TD are just positive, they have not mentioned any of the value. Okay, the system may have damped oscillation for unit step input. Yes, it may have. Okay, zeta can, may be less than 1. Okay, may be greater than 1, because the values of TP DD not given, they are positive. Okay, so zeta, it may be possible that zeta may be less than 1. Okay, the system amplifies the noise. Okay, I'll come to this. And the last is the system has zero steady state error for unit parabolic input. Okay, this is something which is not going to be true. Now see, one of the general effect, I'll first tell you this, a PD controller, one of the general effect of PD controller that you should not derive, and you can say that it decreases the rise time as well as settling time, and rise time decreases means bandwidth increases. Okay, I'll write down this something here. Okay, so whenever we talk about PD controller, okay, whenever we're going to talk about PD controller, okay, it decreases the rise time and hence it increases the bandwidth, because rise time and bandwidth are inversely proportional. Now, whenever the bandwidth increase, okay, noise also comes in, because noise is what? Noise also is a high frequency component. Okay, so whenever bandwidth of a system is increasing, the effect of noise also will increase. Yes. Okay, so effect of noise will also be more. Okay, the noise effect will be more. Okay, so option number C is also correct. Okay, the system will have zero steady state error for unit parabolic input. Now see, what is the type of the system? You see here. Okay, you see, if you only talk about the open loop transfer function, let me write here separately. So that is going to be TP into 1 plus STD divided by S square, meaning that it is going to be type 2. And whenever there is a type 2 system, steady state error for parabolic is finite only. Okay, is given by the formula 1 upon Ka. Okay, Ka is given by limit s tending to 0, S square GS. Okay, so when you multiply S square will get cancelled, and then put S tending to 0, you get TP. Okay, so steady state error is 1 by TP, which is finite. So option number D, okay, they say it has a zero steady state error. Wrong. Okay, I want to choose the wrong option only, na? Okay, the steady state error, as I stated for you, is 1 upon TP. Okay, no need to calculate, you can straight away put the conclusion also. Okay, type 2 system, the error for parabolic input will definitely be finite. It will have zero error for step and ramp, but for parabolic, some finite error will be there. Okay, fine. This was the third one. Moving ahead. Yeah. Which one of the following transfer function represents the Bode plot as shown in the figure? Simple question only. Okay, why? Because you see, there is the initial part having positive slope. Initial slope is 40. Okay, that too 20 into 2. How much? Positive 20. So positive means zeros. The slope, positive slope is introduced by 0. Okay, so this indicates how many zeros at origin? 2 zeros at origin, because initial slope comes because of poles or zeros at origin. Okay, negative slope poles, positive slope zeros. Okay, so there are 2 zeros at origin. Okay, yeah, all the options automatically have it. Now, this is a corner frequency. Simple question it is. This is a corner frequency because slope change. Any slope change point is the corner frequency or break frequency for me. How much is the slope change? 42 minus 60. Okay, how much is the slope change here? Is 100. 42 minus 60, slope change becomes minus 100, because 40 minus 100 you get minus 60. Okay, and minus 100 is like minus 20 into 5. Minus a slope change of minus 20 because of poles. How many poles? 5 poles. At the location 10. Okay, you can now say that there are going to be 5 poles at the origin. Sorry, not at origin, at the frequency omega equal to 10. Okay, so the time constant. Okay, this is the corner frequency. Time constant is known as the reciprocal of the corner frequency, or corner frequency is reciprocal of time constant. Okay, so what is going to be answer? 5 poles. Okay, 1 plus st. The time constant is 1 by 10. Option number C. Okay, some gain can be there which can be calculated if they give some other data, or by this we can calculate. Okay, at omega equal to 10, the initial part has the magnitude of 200, but we don't require. Options is not asking k value, they have left it in k. Two simple observations: zeros at origin and poles at 10. How many poles? 5 poles, because of minus 100. Okay, and there is only one option having the 1 plus s by 10 power 5, 1 plus st power 5. Okay, next. The open loop transfer function of a unity feedback control system is given to you. What is the required value of A that provides a phase margin? Okay, I think these options have missed in this question, but no problem. Let's solve it without the option. Okay, phase margin is given to you. Let me convert this into the frequency domain first. Gj omega as 1 plus as, so 1 plus aj omega divided by j omega whole square. Right, so first of all, what is going to be the magnitude function for this? Okay, mod gj omega under root 1 plus a square omega square, root over x square plus y square divided by omega square. And what is going to be the phase function for this? Angle gj omega. Okay, tan inverse y by x, tan inverse a omega, denominator pure imaginary 2 times, so 90 degree into 2. Okay, this is the phase. Okay, phase margin has been given. So from this itself, I can get the value of A. I think the magnitude part will not be required. Okay, a simple question then. Okay, so what is the phase margin given? The phase margin formula actually is 180 degree plus angle gj omega g. Correct? Right. So what is the phase margin given? 45 degree is equal to 180 degree plus of the angle expression I will write down. Tan inverse of A omega g, and minus 90 into 2 is minus 180. So these 180s got cancelled. So you have tan inverse A. No, I think we will require that magnitude also. Tan inverse A omega g is 45 degree, meaning that A into omega g is tan 45 degree, and tan 45 is 1. A into omega g is 1. Now what is omega g? Okay, what is omega g? We'll have to come to the magnitude form. Okay, so what happens at omega equal to omega g? Magnitude, the Nyquist plot intersects unit circle, or the magnitude or the gain of the system has to be 1. Magnitude equal to 1. Okay, so let's do it. Okay, let's do it. 1 upon under root 1 plus a square omega square upon omega square. Omega is omega g. Okay, this expression has to be equal to 1. Okay, but what I know right now, a into omega g is 1. A into omega g is 1. Correct, na? So I'll put down that value. 1 upon 1 plus a omega g 1. So 1 square will be 1. Divide by omega g square is 1. Okay, so solving this, you are getting omega g square is root 2. Okay, is root 2. Okay, so what is root 2 means 2 power half. So what is going to be omega g is further 2 raised to the power 1 by 4. Okay, now A into omega g1. Question is asking A value, na? What is the value of A? Okay, so A will be 1 upon 2 power 1 by 4 or 2 raised to the power minus 1 by 4 is the answer. Okay. Okay, options have gone missed. Okay, some options like root 2 or 2 power 3 by 2 or something like that, the options were there for this question. Okay, right. This is the fifth question. Okay, also let me tell you that it's a mini mock test, as I told you, containing multiple mixed questions. Okay, so in total 25 questions you are going to see in the session. Okay, fifth is done, so that's why I just told you that total. Be ready for the 25 questions. Okay, sixth one. The characteristic equation of a closed loop system is given to you, s square plus 4s plus 16 equal to 0, resonant frequency. Simple question. What is the resonant frequency formula? Let me tell you what all is required first. Omega r is given by the formula omega n root over of 1 minus 2 zeta square. This is the formula. Okay, now from here, okay, the characteristic equation given, this is omega n square, so omega n is 4, omega n square is 16, then 2 zeta omega n is 4, so omega 4 and 4 cancelled, zeta is 1 by 2. Okay, so completing the answer. Simple formula question, omega n 4 under root of 1 minus 2 zeta square, 2 into 1 by 2 whole square. So this is 4, 1 minus 2 by 4, 1 minus half, or you can call it as 4 into under root of 1 by 2. So 1 root 2 will get cancelled, 2 root 2. Answer has to be 2 root 2. Okay, here it is. Okay, dear. Option number D, 2 root 2 is what is the correct. Consider two control systems with the following transfer function. Consider the control systems with the following transfer function. Okay, system 1 and system 2. What is system 1? Okay, 1 upon 3s plus 1. System 2, 1 upon s plus 1. Okay, comparison of bandwidth. See, for a first order system, okay, for the first order system, what is the bandwidth given by? 1 upon 1 plus st, where t is known as the time constant. The bandwidth of the system, okay, 3 dB bandwidth, omega 3 dB is reciprocal of this time constant, right? Okay, so what is going to be the bandwidth number 1? Okay, time constant is 3, so 1 by 3. For the second system, 1 plus st, time constant 1, so bandwidth is 1 by 1, which is 1. So bandwidth of which system is greater? System 2 is greater, option number B. This was simple. Okay, option number B. Next question. The state space representation of a system is given to you, x dot equal to ax, y equal to cx. Okay, right. If x initial state vector is given, what is the response y t? Now see here, x dot, okay, the general representation of a system is x dot plus b. Okay, then y equal to cx. Okay, if I take u equal to 0, then only we will be able to get this equation, x dot equal to ax. Right, u equal to 0 means in this question 0 input condition is given. In this question 0 input condition is given. Okay, so what is the output we have to find? Find the response yt. So which response it is? It is actually ZIR. ZIR known as 0 input response. The question usually will not use the word ZIR, ZSR, but here, okay, it's a 0 input condition, so the response that will be coming up is the ZIR, 0 input response. And then what is the formula, okay, for ZIR? Okay, so first we need to solve the state vector. Output equation is anyways given to me. Okay, in 0 input condition, okay, in 0 input condition, the x ZIRT is given by the formula phi t into x naught. X naught is the initial state vector given. Okay, phi t, okay, known as, should know that, phi t known as the state transition matrix. Okay, what is the state transition matrix? Okay, phi t is e power at. Okay, and the way to calculate, one of the way to calculate is inverse Laplace of si minus a whole inverse. Okay, this question is going to be simple actually. Our main target in such question is state transition matrix, then only multiply by x0. That is simple. Okay, but why this question is simple, I am telling you. As I just told you, what is the state transition matrix? In general, we solve by this inverse Laplace of Si minus A whole inverse. So first we create the Si minus A matrix, then takes the inverse of the matrix and then take the Laplace inverse calculation. Okay, but you see the A matrix given in this question. I'll give you the direct shortcut. The A matrix is 2003. 2003. Okay, diagonal matrix. Okay, all the elements other than diagonal are 0. So whenever you have a diagonal matrix of the kind lambda 1, 0, 0, lambda 2, diagonal matrix, which you get in the DCF form of the state space representation, okay, the e power at, that is the state transition matrix, okay, which you can again form by this, but solving by this for especially for diagonal matrices, the state transition matrix is also diagonal in nature, given by the formula e power lambda 1t 0, 0, e power lambda 2t, correct? Okay, so for this matrix, what is going to be the state transition matrix is simply e power 2t 0, 0, e power 3t. That's it. Okay, so what is the XZIR? Okay, what is the solution of the state vector XZIR? Okay, as I told you, it is given by phi t multiplied by x naught. Multiplied by x naught. What is the value of x naught? Is 0, 1. The value of x naught is 0, 1. Okay, so now if I multiply e power 2t 0, this is 0 only, then 0 and e power 3t. This is what I get. Okay, this is XZIRT. Okay, this is the xt or XZIRT. Now I want the response yt. So what is the output equation? You see here. Output y is given by 1 to x, where output is generally given by the equation y equal to cx. Okay, or yt is equal to 1 comma 2 xt. What is xt? State vector. Okay, state vector is nothing but a column vector containing both the state variables. Okay, or you can substitute what is the xt obtained. What was the xt obtained? This is the xt obtained in the 0 input condition, 0 and e raised to the power 3t. So when I multiply these two, 1 into 0 and 2 e power 3t. The answer is 2 e power 3t. 2 e power 3t. Option number C. Two e power 3t. Okay. Done. All right. Next question. Number 9. What is the fundamental frequency of the signal? Cos pi by 4n plus sin pi by 8n. Cos pi by 4n plus sin pi by 8n. Okay. Right. The fundamental frequency and whether the signal is aperiodic. Now you see here. Okay. Now you see here. It's a DT signal. Okay. Anytime in DT sinusoid, the important point that you must note is whether it is A cos omega n or A sin omega n, cosine or sine anything, any sinusoid. Okay, this is periodic if 2 pi by omega is rational. Okay, 2 pi by omega is rational. Okay, so first I will check individually both of them. Okay, what is the 2 pi by omega for this? 2 pi by 8, that is clearly 16. Okay, directly integer. 2 pi upon pi by 4, that becomes how much? 8. Both are integers only, integer also rational. Okay, see, the condition is it is periodic if 2 pi by omega is rational. Okay, then final period is given by, see, in discrete time signal, discrete time domain, the final period also must be integer. What I told you, 2 pi by omega rational, it may sometime be possible 2 pi by omega is 2 by 3. So yes, signal can be periodic, but it cannot have the period 2 by 3. Why? Period has to be integer. Discrete time only integral time is allowed. Okay, so 2 by 3, if the 2 by 3 is the period, 4 by 3 is also period, 6 by 3 is also the period. Any integral multiple is the period. And if you take 6 by 3, you get 2, which is a perfect integer. That means period generally is given by any multiple of 2 pi by omega, so that finally you get integer. Okay, this period has to be finally integer. That's the idea. It has to be integer finally. Okay, now here you see this is already integer. Okay, so no need to, do any multiples or anything like that. Okay, both of them are integer. Okay. Now, addition of two dt periodic signals will anyways be periodic because both the time periods are integer. Ratio of time period anyways will be rational number. So, what is going to be the final time period? Final time period is going to be the LCM of 8 or 16, and that is 16 itself. The lowest common multiple is 16. Okay. Okay. We actually wanted frequency. Okay. No. No. I think question should be time period, because what I'm getting is the time period 16, frequency will be 2 pi by 16, will not match. Okay. So fundamental time period only. The question is fundamental time period only. Okay. And that is option number C. Okay. Option number C. Correct, na? Yeah. Answer is 16. Okay. Next question. Okay. So basic question on periodicity. Next question. Convolution of the signal un plus 1 with hn equal to un minus 3. Okay, what is there? Simple question it is. Okay, what is the step convolution step? Discrete time domain. Step convolution step is r of n plus 1. Shifted ramp signal. Okay, in CT domain, the result is different. In CT domain, the result is step convolution step is ramp only. Ramp starting at origin. In DT domain, it is un convolution un is r of n plus 1. Okay, now apply the time shifting cases of convolution. If any one signal is time shifted, output is time shifted. But here both the signals are shifted. Un plus 1, convolution un minus 3. The output is shifted due to both r of how much? Plus 1 here and minus 3 here. N here, right side, n should be replaced as n plus of 1 and minus 3. And then this plus 1 anyways is separate. So answer becomes n minus 1 then. R of n minus 1, option number B. Check it out, please. Option number B, R of n minus 1 has to be the correct answer. Next question. Okay. What is there in the next question, dear? Okay. The input-output relationship of the following two systems is given to you. Y1t is x2t, y2t. This has to be y2t. Okay. Is sine of xt. Which of the following statement is true? Okay, the options are talking about which of them being causal or non-causal. Which of them being causal or non-causal. Okay, let's do it. What is there? Okay, so simple. See, output depending only on present or past makes the system causal. If there is the involvement of future value, okay, the system is non-causal. This is time scaling case, 100% non-causal, because suppose if I ask you what is y11 is x of 2. Okay, the value is x of 2. Okay, the value of the output required at t equal to 1. Okay, for calculating the output at t equal to 1, we need the value of the input at t equal to 2, and 2 means future, ahead time. Okay, so whenever the output depends on future values of the input, the system is non-causal. Okay, so this first one is non-causal. Second one, y2t sine, whether it is a sinusoidal of input, exponential of input, or yt is 5xt, square of input, anything. You have to see if you are calculating output at any time t, input also required at the same time. This is also present only. Okay, this is also present. Output and input, okay, at the same time. That means present time. So this case is causal. Okay, so y1t is causal. Y2t is non-causal. Option number B, simple question. Consider the following cascade of two subsystems with the impulse response given. Okay. What is this system given? Okay. The step response of overall system will be how much? Okay. Now see, both the systems have the impulse response h1t 1 by pi t, and that is equal to minus of h2t. Okay. So what is h1t? 1 upon pi t. What will be h2t? Minus 1 upon pi t. Okay. Now dear, this question can be solved easily if you remember what is 1 by pi t. See, 1 by pi t actually 1 by pi t as the impulse response is the impulse response of a Hilbert transformer. Hilbert transformer, also known as pi by 2 phase shifter. also known as the pi by 2 phase shifter. Okay, that means, a quick recap. Okay, if you take the Hilbert transformer having the impulse response 1 by pi t, okay, or in the frequency domain h omega is given by the frequency response of this system is minus j signum omega, so that if you apply the input xt in time domain, you get the output yt, which is given by input xt convolution with the impulse response 1 by pi t. Or in the frequency domain, it's better to analyze such case. If you apply the input having the Fourier transform y omega, sorry, x omega, the output Fourier transform y omega is simply given by x omega e raised to the power minus j pi by 2. Okay, pi by 2 phase shifter, that's what I told you. Okay, finally it's pi by 2 phase shifter. Okay, so dear, if double Hilbert transformer comes in cascade any time, okay, if two Hilbert transforming is cascaded, okay, see, this is the input xt having the Fourier transform x omega, this is the final output yt having the Fourier transform y omega, which will be x omega e raised to the power minus j pi. Why? Because two Hilbert transformers in cascade, e power minus j pi by 2, again e power minus j pi by 2. So net phase will be 180 degree, e power minus j pi. But e power minus j pi is minus 1. So actually y omega is minus of x omega. Okay. Now what does it mean? Okay, y omega is minus of x omega. That means in time domain also you can say yt is minus xt. Yt is minus xt. Okay, so that means if I take two systems in cascade, what is the overall impulse response? If two systems are in cascade, the overall impulse response is convolution 1 by pi t, convolution 1 by pi t. But when you say yt is minus xt, okay, yt is minus xt, yt actually should be how much? Yt actually should be the input xt multiplied, convoluted with the overall impulse response. Okay, convoluted with the overall impulse response. But if yt is minus xt, this impulse response should be a minus delta t signal. Okay, because the output is same as xt. See, any signal when you convolute with impulse, okay, just wait a second here. I'll add up one more slide. xt, convolution delta t, is actually given by xt. Okay, so if I am telling you yt is minus xt, means yt can be written as xt convolution with minus delta t, right? Okay, so this is the overall impulse response. Okay, this is the overall impulse response. So 1 by pi t convolution 1 by pi t is minus delta t. Same thing I will apply here. Okay, same thing I will apply here. And what will I say that? The net convolution, the question is asking what? The step response. Okay, forget, let me calculate the overall impulse response. Overall impulse response is 1 by pi t convoluted with 1 by minus 1 by pi t. Okay, so minus you can take outside. 1 by pi t convolution 1 by pi t is minus delta t. So minus minus plus only. This is delta t. Okay, so impulse response here is delta t. Impulse response here is delta t. Correct? Impulse response here is delta t. Okay, now if the impulse response is delta t, okay, so the question is the step response. What is the step response? Step response means whenever the input applied is ut, okay, the output is what is known as the step response. The output is known as the step response. Okay, so what is the output yt? Okay, the output yt should be given by input xt. Okay, input xt convolution with the overall impulse response, but the overall impulse response is delta t only. Okay, so what is yt? Is xt, and xt means unit step. So response output also will be a step signal only. Okay, option number B, step function. Step function. Okay, right. Or once again, right, what is there? If you wanted, you can again solve it in the frequency domain only. Okay, since I already gave you the frequency domain introduction, just a second, why it has not come up here. Okay, fine, let it be, why to waste time. Okay, what I am telling you, another approach is, okay, since the first system is 1 by pi t, another one is minus 1 by pi t, and 1 by pi t means Hilbert transformer. So if you apply xt here, this is x omega. Okay, what do you get here? X omega e power minus j pi by 2, because this is the Hilbert transformer. What will you get here? Okay, negative of the Hilbert transformer. Okay, that means minus of x omega e power minus j pi by 2. This is the input to the second block. Okay, it will further shift this input value by 90-degree phase difference to e power minus j pi by 2. Okay, so overall this is minus of x omega power minus j pi, but as I told you, further e power minus j pi is minus 1. So minus minus plus, it is x omega. Okay, so y omega is x omega. Okay, so yt is xt. Okay, xt you have to apply as ut, the answer also will be ut. Okay, answer also will be ut. So answer anyways will be step function. I've just shown you two different ways of solving it, so that we have a basic discussion on the Hilbert transformer as well. Okay, anyways, next question for you. A signal xt has the Fourier transform shown in the figure. What is the value of integral 0 to infinity mod xt square? Now Fourier transform is given and the question is on time domain. Okay, first of all, okay, this is a slight good question. Okay, see, what is x omega? X omega, if you observe, is definitely real. It's all the values are real. There is no j axis here. There is no j term here, and it's also even. Now Fourier transform, as seen, is real and even. Fourier transform is real and even if signal xt is real and even. If a signal is real and even, then the Fourier transform is real and even. If the signal is real and even, then the Fourier transform of it is also real and even. Correct? Is also real and even. Done. So now you see. Okay, now you see integral 0 to infinity modulus of xt whole square. Why I am talking about this even property is because this question actually has to be solved by Parseval's. Because the question is on time domain and the frequency information is given to you. Time domain, that to energy formula, integral mod xt square. Okay, so as per Parseval's integral, okay, of for real signal. Anyway, signal is real, na? Okay, mod xt can simply be written as xt only because the signal is real only. Okay, mod xt square will be x square t, I mean. Okay, right. Okay, so integral minus infinite to infinite x square t dt is given by 1 upon 2 pi integral minus infinite to infinite modulus x omega whole square d omega. This is what it is. But whenever a signal is even, integral property for even function, integral minus a to a is twice integral 0 to a, correct? That's what you know, is twice integral 0 to a. Okay, so I can write down twice integral 0 to infinity x square t dt is 1 upon 2 pi. Now integral mod x omega square, integral minus infinity to infinity mod x omega square, where mod x omega is triangular function. So area under the square of triangle, that's what you learn in the energy signal, at least rectangle, triangle, two very basic common sense, common shapes. Okay, area under the square of a rectangular function is given by amplitude square into duration. How much is the duration? Minus 4248 divided by 3. This is the formula. Amplitude square into duration divided by 3. Okay, I write it this way for triangular pulses. Amplitude square into duration by 3. Okay, so now the question is only integral 0 to infinity. So this 2 can be divided on the right side. Integral 0 to infinity x square t dt will be how much? Okay, this 2 also you divide here, so 1 upon 4 pi into this 1 4 will get cancelled. Okay, so it's only going to be 4 into a 32, 32 by 3. Let me write down the final answer. It is looking like 32 upon 3 pi. Okay, 32 by 3 pi. Yeah, here it is, option number C. 32 by 3 pi, option number C, correct. Next one. The 4-point DFT, the 4-point DFTs of xn and yn is given to you, xk and yk. Okay, what is the circular convolution of xn and yn is wn? What is the value of w2? Now see, what is the circular convolution of xn and yn is wn? Okay, but what is given to you? The DFTs are given to you. Okay, what does it mean? The DFTs are given for you. Okay, the DFTs are given to you. Okay, see, let me just write down an equation. Circular convolution wn is the circular convolution of xn and yn. Okay, xn and yn. Okay, so if you convert this to the DFT, if you convert this to the frequency domain, yk is given by xk, wk is given by xk multiplied by yk, convolution in time, multiplication in frequency. Okay, so you don't actually have to do the circular convolution of xn and yn. Why? Because x and y are not given, their DFTs are given. Using their DFTs, you can obtain the wk. You can obtain the wk. Okay, so what is the wk? If I multiply, point to point, if you multiply, first 22 into 8. Okay, 22 into 8, that is the first sample. Then next, minus 4 plus j2 multiplied by minus 2 minus j2. Next, minus 6 into 0. And the last element will be minus 4 minus j2 multiplied by the minus 2 plus j2. This is what is going to be the wk. Okay, this is what is going to be the value of wk. And then we'll come to w2, only w2, that is in the time domain. This is the frequency domain, wk information. Okay, so let me actually solve this first. What is this wk? 22 into 8, 176. Then what about this calculation? Let me do, okay, this calculation, how much it will be? Rather, I'll do it here separately. Minus 2 I'll take outside here, so I'm left with minus 2 plus j to be multiplied by, from here also you take minus 2 common only. Okay, sorry, I'm taking 2 common from here. So 2 if you take common, minus 2 plus j. Okay, and then from the next one I am taking minus 2 common, so then you have 1 plus j. Okay, you have 1 plus j. So this is going to be minus 4 and then minus 2, minus 2j plus j minus j and minus j square. Sorry, plus j square will be minus 1. So I think this is minus 4 into minus 3 minus j. Okay, just check the calculation once. Okay, so yeah, looks okay only. This is minus 2 minus 2j plus j is minus j and j square, correct. Minus 3 minus j. Okay, so this is minus 4 multiplied by minus 3 minus j. This minus 6 into 0 is 0. What about the other one? Okay, what about the other one? From other one, let me convert to the above form only. What can be there? If you take minus 2 outside this time, only conjugate part difference is there. Na? Next one will be, again if I take 2 common, so minus 2 minus j and then, so I think the result also will be conjugated. Na? That's it. Why to do it separately? Okay, so the next result will be minus 4 into minus 3 plus j. Okay, now see, let me rewrite these numbers here. What is the wk I have obtained? A DFT question. Okay, wk is coming out to be 176. Then multiply here actually minus 4 also, so you'll get plus 12 and plus 4j. Okay, so 12 plus 4j, next 0 and next is 12 minus 4j. This is the wk obtained. Okay, now w2. Okay, central ordinate w2. The question is w2. Okay, where this value 2 is n by 2. Okay, so in the time domain, okay, this value Wn by 2 is actually given by 1 upon n summation of minus 1 power k wk, that is alternate plus minus will come. Okay, what is the meaning of this? 1 by n means 1 by 4. First value will be W0. If you take K0, so W0, that is the first value. Then if you take K1, odd value of K, minus 1 power 1 will be minus. That's what I'm telling, alternate plus minus. Okay, so next will be minus of this value, minus of 12 plus 4j. Next will be plus of 0, whatever this value, plus, and then next again minus of this value. This is one of the basic DFT properties. So then the answer is 1 by 4, 176. Okay, see 4j minus 4j anyways will cancel, so only minus 12 and minus 12. Total you subtract 24, so 152 divided by 4. Okay, 76 further by 2, how much? 38 it is. 38 it has to be. 38, option number A. So see, many questions in ISRO exam can be direct, but few good questions will also come up. Okay, so that's why I'm taking the mixture of them. Okay, so I've just tried to take the mixture only. Okay, now let's go to the next question. Okay, this one was a decent, good question. The direct from structure of a FIR, that is finite impulse response filter, is shown in the figure. The filter can be used to approximate what? Low pass filter, high pass filter, band pass filter, band stop filter. Okay, simple. Let me first write down the equation here. What is given? This is input xn. Okay, multiplied by 5. So what you get here is 5xn. This is a unit delay, 2 cascaded unit delay. That means twice unit delay, it becomes x of n minus 2. It becomes x of n minus 2. Further multiplied by 5 here, so 5xn minus 2. This is minus, this is plus. So what is the final output equation then? Final output equation, 5xn minus 5xn minus 2. Okay, converting to the DTFT, frequency information is required for filter analysis. Na? So y omega will be 5 xn DTFT x omega minus x omega e power minus j2 omega. Okay, so what is the value of y omega? Is 5x omega, or let me get the frequency response of the system. Okay, the frequency response of the system h omega is given by y omega divided by x omega, and that will be 5 1 minus e power minus j2 omega. Now if I take up any low frequency, okay, suppose omega 0, so what is the h0? Is going to become 5 1 minus e power 0. E power 0 is 1. Okay, 1 minus 1 0. It cannot be a low pass filter because definitely it is blocking the low frequency. Okay, and then I'll go to a high frequency. I'll also take a mid frequency, but first let me go to high frequency, and in the DT domain the high frequency is taken as pi, you know. It is a DT domain question, DT filter question. So what is the h pi? 5 1 minus e power minus j2 pi. E power minus j2 pi is also 1 only. 0. It is not a high pass filter also. So I will take a mid frequency, that is pi by 2. Okay, and what is h of pi by 2? 5 1 minus e power minus j pi by 2. Sorry, e power minus j 2 omega. So 2 omega will become pi. Okay, and 1 minus minus of 1. Okay, e power minus j pi is minus 1. So net answer now becoming 10. 1 plus 1 to 5 to 2, 10. Okay, so the mid frequency gain of the system is 10. The mid frequency gain of the system is equal to 10. Okay, so that means it is only passing some mid, okay, some band of frequency in the mid. It is a band pass filter. Okay, approximately if I wanted to show you now the magnitude spectrum, okay, it will be for the positive side, it will be looking like this. Okay, a rough sketch. At pi the gain was 0, at the 0 gain is 0, at the mid frequency gain was higher. That means there is some band of frequency. Okay, there is some band of frequency, okay, which is being passed, okay, with a considerable gain. Okay, then we know 1 by root 2 point to define the 3 dB bandwidth and all. Okay, we don't need any bandwidth and all. Just telling you. And of course, all these DTF, all this mod of h omega, na, so magnitude spectrum anyways is even symmetric. So it's like going to be like this. Okay, done. This is how it is. Chalo. So anyways, the answer for the question is a band pass filter. Option number C is a band pass filter. Next question. Okay, a mathematics question. Consider an unbiased cubic die with the opposite faces colored identical and each face colored red, blue and green such that each colors appear only 2 times on the dice. Okay, so there are 6 faces on the dice, now each color appearing 2 times. Okay, twice green, twice red and 2 faces are blue. Okay, if the die is thrown thrice, what is the probability of obtaining red color? So see, first of all, forget the die being thrown twice. If I think about a single dice, what is the probability of red? Okay, it is 2 faces which are red colored and total 6 faces are there. So the probability favorable by total is 2 by 6, or that is 1 by 3. Correct, na? Now, if the die is thrown thrice, okay. See, one point is you can apply and solve the question by binomial, but only 3 tosses. Now we can solve it directly also. Okay, probability of obtaining red color on the top face at least twice. Probability of at least 2 red. Okay, that means probability of red. Okay, probability of obtaining at least 2 reds. That means probability of 2 red or probability of 3 red. Now this is simple. What is the probability of 3 red? Okay, probability of first red, second red, third red. First red and second red and third red. Okay, and means multiply the respective probabilities. Plus, it could be 2 reds also because they told at least 2 red. Okay, 2 or more. So it can be 3 reds or 2 reds. Okay, but what is the probability of 2 reds? So probability of a red 1 by 3, probability of a red 1 by 3, and third should not be a red. So what is the probability of not a red color? 1 minus 1 by 3, 2 by 3. But which one color is not red? Okay, there are 2 reds, so one is non-red. Which one is non-red? Okay, that can be third also, second also, first also. Okay, so we have to take 3 cases here. Okay, why 3 cases? I will highlight here separately. Why 3 cases? Okay, it could be like red, red and not a red. It could be red, not a red and then not red, red, red. I want 2 reds, na? Okay, so the third color, okay, can be, the other color. It could be how much? Blue or green. But where is that other color? Third position, second position, first position. That is why I directly multiply by 3. Because numbers will be same here. 1 by 3, 1 by 3, 2 by 3. What will you write here? 1 by 3 into 2 by 3 into 1 by 3. Same calculation wise, same only, na? Okay, yeah. So this is how much? 3, 3, 3, 27. Let's take it common. The numerator 2, 3, 6 and here it is 1. So 7 by 27. Simple question only. This answer is how much? 7 by 27. Option number A. 7 by 27. That's it. Next. Consider the function 2x minus 3x square in the domain minus 1 comma 2. What is the global minimum of fx? What is going to be the global minimum of fx? Okay, yeah, let's do it quickly. What is there in this question? Okay, now see, first let me calculate the stationary points. What is f dash x? So 236 x square minus 326x. Put it equal to 0. If I take 6x outside, I am left with x minus 1 equal to 0. So x equal to 0 and 1 are stationary points. Now, okay, out of the stationary points, okay, the stationary point may be a local maxima point or local minima, but I don't want local maxima, local minima. I want global minima. Okay, and if you only are interested in global maxima or global minima, so don't waste time in confirming who is local max, who is local min. What is the method I have explained you earlier also? Just take this calculation. What is the closed domain given? Minus 1 comma 2. Okay, because the global maxima or global minima can either be at the stationary points or endpoints. At endpoints. Okay, this global will always come either at endpoints of the given boundary, given interval, or stationary points. Okay, so that means I'll just do basic calculation here. F minus 1, okay, then F0, okay, then F1, these are the 2 stationary points, and then the end point F2. Okay, these are two endpoint, these are two stationary point. F minus 1, let me calculate now. Minus 1 cube is minus 1. Minus 1 square will be 1 only. So this value is minus 5. Okay, F0. F0 is simply 0. F1, 2 minus 3, minus 1. F2, so 2 into 2 cube, 16. Minus 3 into 2 square, 12. Correct, na? 2 into 2 cube, 16, and 3 into 4, 12. This is equal to 4. Now, what you just have to see, why I am telling you this is simple, because you just have 4 calculations, 2 boundary and 2 stationary. You just look and compare who is the maximum or who is the minimum value. The question was minima. Okay, so out of all these, the minimum value is minus 5. Okay, right, and the maximum value is plus 4. Okay, so minimum is minus 5, option number A. Sometimes they can also ask, be careful in the question, the global minima of fx occurs at what point? Global minimum value is minus 5, agreed. Okay, but at x equal to minus 1. Similarly, global maximum value is 4, and that is at x equal to 2. Okay, but right now they ask minimum value. Okay, it is minus 5. It is minus 5, option number A. Okay, dear. Option number 8 is next question. Consider a 3 cross 3 real symmetric matrix such that two of the eigenvalues are A not equal to 0 and B not equal to 0 with respective eigenvectors given to you. If A not equal to B, okay. Real symmetric matrix property. For a real symmetric matrix, okay, if lambda 1 not equal to lambda 2, then the eigenvectors are orthogonal. Okay, eigenvectors corresponding to distinct eigenvalues are orthogonal. Orthogonal eigenvectors V1 perpendicular to V2, or the dot product, okay, V1 dot V2, or in matrix notation we write it as V1 transpose V2 is 0. And this is what? This is the dot product expression, x1 y1, x2 y2, x3 y3. Okay, this is nothing but the dot product representation between the two vectors. Let's say this is the eigenvector V1, let's say this is the eigenvector V2. This is nothing but V1 transpose V2, which has to be 0. Real symmetric matrix direct property, option number D. Okay, for a real symmetric matrix, two important points. Number 1, all the eigenvalues are real. Number 2, eigenvectors corresponding to distinct eigenvalues should be orthogonal. Okay, so answer is D. Okay, you can directly write down the answer. All right. Expansion is given, it is corresponding to which function? An expansion is given and it is corresponding to which function? See here. Let's make it first of all a little bit simple. Okay, the expansion contains more or less x, x square, x power 4, x power 5. So it contains odd powers also, it contains even power also. So definitely option number B is not correct. Okay, why? Because if you see e power cos x, take the cos of minus x, cos x only, na? Okay, so option number B is the even function, and whenever you have an even function, the expansion should only contain even terms like x square, x power 4, okay, etc. Similarly, x into sine x also. Okay, you replace by minus x. What do you get? Minus of x, sine of minus x. Okay, minus of x, sine of minus x. But what is sine minus x? Minus sine x. Minus minus plus, so x sine x. So same you will get e power x sine x. That means option number B and D are even functions. Okay, and even function expansion can only contain, for even function, the Taylor expansion can only contain okay, even power will include x power 0 also, but it will not include the odd power like x power 1, x power 3, etc. Okay, so definitely B and D cannot be the correct. So now we have to choose between A and C, e power 10x, e power sine x. Okay, let me start with C, because the derivative with respect to sine will be more easy. Okay, sine derivative cos, cos derivative minus sine. But tan derivative sec square, then sec square derivative 2 sec x tan x again. Okay, sorry, 2 sec x and again into sec x tan x. So that chain will be more longer. So let me try with option number C first. Okay, let me try with option number C first. Okay, suppose if I wanted to try for option number C, e power sine x. Okay, better I'll try here. Come here. Where's that gone? This one, huh? Fx is suppose e raised to the power sine x. Okay, so what is f dash x? Okay, or first, what is f0? E power sine 0. Sine 0 is 0. E power 0 is 1. Then f dash x. Okay, the derivative, exponential derivative is exponential, but by chain rule, sin x derivative is cos x. What is f dash 0? F dash 0 will be e power sine 0, 0. Again, cos 0, 1. So this is 1 only. This is also 1. Okay, right. So that's what, see, what I am getting is, this is the, in the Taylor's expansion, this is f0 term. Okay, then what is this? This is the f dash 0 term, which is again 1. What is this? From here you can say f double dash. Okay, what is the next coefficient? What is the next pattern in Taylor series? F double dash 0 divided by factorial 2 into x square. So this f double dash 0 is 1 because it has to be divided by factorial 2 anyways. Okay, what about this? Okay, x power 4. Now what is the coefficient of x power 4? f4 0 upon factorial 4. This is 1 by 8. Okay, so what is f4 0? 4 factorial is 24, 24 by 8, this has to be 3, like this. Okay, so what I'm telling you, f0 is 1, f dash 0 is 1, that is matched anyways. Now f double dash. Okay, actually if this is correct answer, the third derivative is 0. No x cube means third derivative is 0. Okay, so what is the second derivative? Okay, now chain rule will come. Okay, so first I'll take e power sin x derivative, e power sin x again into cos x, so it becomes cos square x. Then cos x, e power sin x as it is. Okay, cos x derivative minus sin x. Okay, but what is the value at 0? F double dash 0. E power 0, cos 0, 1, plus again e power 0 and sin 0 is 0. So this is net 1. Yeah, so f double dash 0, I want 1. Okay, that is also tallied. Okay, now f triple dash, third derivative of this function. Okay, so better you can take e power sin x common, and constant in the first case, then cos square x derivative. Cos square x derivative will be 2 cos x minus sin x. Okay, minus 2 cos x sin x, and then minus sin x derivative minus cos x plus, okay, e power sin x derivative again, e power sin x into cos x, and then the bracket term will be constant, cos square x minus sin x. Okay, now if I put down the value 0, f triple dash 0, okay, e power 0, okay, 1, e power 0. Now sin 0 is coming 0, okay, minus cos 0, 1, plus again e power 0 into cos 0, 1, again cos 0, 1, and sin 0, 0. Okay, so net answer e power 0 is 1, so this is minus 1. Here it is plus 1. Yeah, minus 1 plus 1, 0. Correct. Okay, so third derivative is 0. So option number C looks like the correct option. Okay. Option number C is what is giving you the correct answer. Okay. Next question. The integral 1 upon 2 pi, integral 0 to 2 pi, sin t minus tau cos tau d tau. Okay. Sin t minus tau cos tau d tau. Right. See, what is there in this question? It's an integral with d tau, it's an integral with tau. Okay, and sin t, see, number one, you can expand this, or you can even, since t is constant only, now you can even replace it. Okay, what is there? I'll just solve it directly only, na? You can solve it directly only. Firstly, if I apply sin a minus b, so sin a cos b, sin a cos tau minus cos a sin b, so minus cos t sin tau whole multiplied by cos tau d tau. Okay, now 1 upon 2 pi, it's an integral with tau, so t is constant. So in the first term, I'll take sin t outside. Okay, integral of cos square t. What you are left with is integral cos square tau d tau. Okay, and then 0 to 2 pi. And then next, 1 upon 2 pi outside. And in the next, I can take cos t outside. Okay, and then you have integral of sin tau cos tau d tau. Limit 0 to 2 pi. Okay. Now further, you can write down this integral as 1 upon 2 pi sin t cos square t. Cos square t, it will be better if you write it as 1 plus cos 2 tau. 1 plus cos 2 tau by 2 d tau, 0 to 2 pi. minus of cos t. Okay, now this can be written as integral sine 2 tau by 2, because sine 2 tau is 2 sine tau cos tau, the 2 will get cancelled. Correct. So then finally this is equal to 1 upon 2 pi. The first one is sine t. Now integrating here, see 1 by tau, 1 by 2 d tau integral tau, then cos 2 tau integral. Okay, what is going to be cos 2 tau integral? Okay, sine 2 tau by 2. Further 1 by 2 and then sine 2 tau by 2. Then next, what is there next? Minus cos t. Okay, this is done. Then 1 upon 2 pi here also. Finally, I'll split the 1 by 2 pi. So 1 by 2 pi here also. Cos t common. Okay, and then sine 2 tau integral will be minus cos 2 tau by 2. Minus cos 2 tau by 2, and 2 is already there, so 2 to 4. Okay, limit 0 to 2 pi. But the simple point is, see, limit 0 to 2 pi. Okay, on sinusoid function. Now you see here. Okay, if you put the upper limit here, sine 4 pi is 0, lower limit sine 0 is 0. So this is eliminated. Here also, cos 4 pi 1, cos 0 is 1. So upper minus lower limit same. Okay, so what is the only answer? 1 by 2 pi sine t, and here limit will definitely come. 2 pi minus 0 is 2 pi, divide by 2, this is pi. Okay, minus 1 by 2 pi into only cos t. Into only cos t. Okay, so this becomes, okay, the final answer then looks like, it is not matching with our answer option then. Sorry, second term what I am telling you is multiplied by 0. So only this is left. Now pi cancel, half sine t. Sorry, correct only, na, half sine t. Okay, half of sine t, option number D. Okay, half of sine t. This is what is the correct answer. Okay, right. Half of sine t. This is what is the correct answer. Let me check it. I think okay only. Yeah, what is the correct only? Okay. Yeah, anyway, so let's move ahead to the next question then. Okay, yeah, next question. Directional derivative. Okay, directional derivative of this function at the point minus 1, 1, 3 in the direction of the vector. See, directional derivative of any scalar function f at some point p, suppose this is the point p, okay, in the direction of some vector, suppose a, suppose this is the vector a, is given by what formula? Is given by gradient of f at the point P dot product with a hat. A hat is the unit vector along the direction of A. Okay, so here the answer is going to be, gradient of f. Now, what is going to be the gradient of f at the point P? Okay, so first let me calculate the gradient. What is the gradient formula? The gradient formula is given by I del f by del x plus j del f by del y partial derivative with y plus k del f by del z. Okay, right. So yeah, let me solve it here. So I del f by del x. What is the partial derivative with x? Y z constant, x derivative 1 plus j partial derivative with y, x z will be left, plus k cap x y constant, partial derivative z with z is 1. This is to be calculated at the point P, which is minus 1, 1, 3. I'll substitute the value. Dot product with a hat. Now, what is a hat? Vector a divided by its own magnitude. Okay, so vector a, right, let's write down the values only directly. Vector a, I minus 2j plus 2k divided by its magnitude, that is root over 1 square plus 2 square plus 2 square, and the question is almost finished. Put down here y into z, 1 into 3, 3i cap. Then x into z, so minus 3j cap, and x into y minus k cap. This is to be dot product with I minus j plus 2k divide by 3 under root of 9. Okay, so now when I take the dot product, 3, then minus 3 minus 2 plus 6, and minus 1 into 2 minus 2, whole divided by 3, 9 minus 2, 7 by 3. Final correct answer, option number C. Option number C, final correct answer. Done? Okay. All right, next question then. Microprocessor, view from the microprocessors. What is the content of the accumulator of 8085 microprocessor after the execution of XRI F0? After the execution of XRI. Now see, what is the role of this instruction? XRI, XOR immediate. Okay, F0H, H for hexadecimal representation. Okay, it will XOR the contents of accumulator with the F0 and the result is stored in accumulator. The result is stored in accumulator. Okay, what is happening? Okay, what will be the contents of the accumulator? This is what? This A is my accumulator only. Okay, right. Now A XOR F0. Okay, see, remember that XOR simple property, if you have any bit X, if you XOR with 1, and if you have any bit X, if you XOR with 0, what happens? Okay, X XOR 0 is X only, but if you take X XOR 1, it is given by X bar. It is given by X bar. Okay, so A XOR F0, I mean, let's say the number in the A, okay, the number in the A, some 8-bit number like A7, A6, A5, A4, A3, A2, A1 and A0. You are going to do the XOR with how much? You are going to do XOR with F0. What is F? 1, 1, 1, 1. Converting to binary, then 0, 0, 0, 0. Okay, so anything XOR with 1, okay, will be complemented. So all the upper 4 bits is complemented. X XOR 0 is X. A3, A2, A1, A0 is same. Okay, so what is there? Only the upper nibble of the accumulator is complemented and the lower nibble is unchanged. Option number B. Option number. It's a basic XOR question. Only thing is you must know the instruction XRI, XOR immediate. Okay, and the basic rules of XOR. That's it. Very simple question, but these are very expected type of questions. Okay, very simple type of question they put from microprocessor many a times. Okay. The clock frequency of 8085 microprocessor is 5 megahertz. If the time required to execute an instruction is 1.4 microsecond and the number of T states. See, now the time required to execute particular instruction is given as 1.4 microsecond and the time required is given by actually the number of T states, because one T state takes one clock cycle, okay, multiplied by the time period of the clock. Okay, that's what I'm telling. One T state takes one clock period. Okay, so number of T states into clock period gives the total time to execute the instruction. Okay, that is the very fund of machine cycles and T states you must know. Okay, so now 1.4 microseconds, this should be equal to the number of T states, suppose n, into the time period of the clock. Now frequency of the clock is given. Okay, the time period of the clock becomes 1 upon f clock, correct? Right, so what is the value of n then? 1.4 microsecond 10 power minus 6 multiplied by frequency of the clock, which is 5 mega is 10 power 6. Cancellation will happen. 1.4 into 5, final answer simply 7. Okay, so such an instruction will have 7 T states. Such an instruction is going to have 7 T states. That's it. Simple one, option number D. 24. The 8085 microprocessor accesses two memory locations, 2001 and 2002. That contains the 8-bit numbers 98 and B1 respectively. The following program is executed. Okay. At the end of the program, the memory location 2003 contains the number in the decimal form. In the decimal form, not from, in the decimal base 10 form. Okay, now let's read here. What is happening? LXI now. LXI is load register pair immediate. It will load the given 16-bit data. 16-bit in binary, of course, means 4 in hexa. Okay, that is the register pair. H is for register pair HL. Okay, gets 2001. Okay, of course, H will get 20, L will get 01. Then MVI move the immediate data to the accumulator. The accumulator gets the data 21. Then INXH means increment the register pair value by 1. So HL will now become 2001 plus 1, so that is 2002. Okay, then add M. Now M, memory pointer in 8085 microprocessor, okay, which points to the memory location, okay, whose address is stored in the register pair HL. Very important point and produces very frequent question. So add, okay, of course, mostly in arithmetic and logical operation, the by default operand, one of the operand is accumulator. Add with accumulator only. Okay, so accumulator contents are added with the contents of the memory location. Okay, and the result is stored in the accumulator. Which memory location? Okay, the memory location represented by the contents of HL. So what is HL? Recently HL was 2002. Okay, now you see what is the accumulator content. I loaded accumulator with the data 21. What is the contents of the memory location 2002? How will you come to know? I am not asking you to add 2002. I am asking you to add the contents from 2002 that is given in. Okay, the 8085 processor accesses the memory location these two that contains the 8-bit numbers. So 2002 contains B1, 98 and B1 respectively. So take the data B1. Okay, this is going to be B1. And if I add lower 1 plus 1, 2, B plus 2, D. Okay, D2. Okay, now INXH. Okay, INXH, again the register pair HL value contents will be incremented. 2002 plus 1 is 2003. Okay. Now move M comma A. Okay, that means move the contents of accumulator to the memory location pointed by same logic I told you. That means, okay, the contents of the memory location will be equal to A is copied here. Okay, that means the contents of memory location pointed by the HL contents. HL is now 2003. Will get A. Now finally question is what? At the end of the program, memory location 2003, correct? The memory location 2003 will contain what data? Will contain the data from accumulator. What is the data in accumulator? We calculated D2. Now this D2 is in hexa form. The question is asking you to convert in the decimal form. Right. So in the decimal form, okay, now D is how much? 13. Okay, into 10 power 1 and then 2 into 10 raised to the power 0. That's it. That's the decimal conversion. 132. 132 is the decimal number. Okay. Okay, I think options are not there. Answer is 132. Simple one. Answer is 132. Convert to decimal. Okay. The digit D means 13 multiplied by 10 power 1 because we are converting to base 10. I'm so sorry. Okay, we are converting to decimal. The base of the original number is 16. Okay, plus 2 into 16 power 0. Okay, so this is actually 13 into 16. So that should be how much? 160 and 48. 208 plus 2. 210 it should be. 210 in the base 10. Okay, 210 in the base 10. You just check up the calculations. I think okay only. Right, 210. Okay. Digit into base power position, base of the actual number. By mistake, I took it as 10. Okay, the answer is 210. Okay, next question. 25th. Okay, loop question. A software delay subroutine is given to you. A software delay subroutine is given as below. Okay, delay MVI H, 255D. D for decimal. I mean, this 255D here means 255 decimal or 255 in base 10. Okay, MVI L, 255D. That means H and L are loaded with the 255 decimal number. You can convert to the hexa if you want. Okay, right. And you know, what is this? This is actually, if you want in hexa, this is FFH because in an 8-bit atmosphere, 255 is the highest decimal number that can be stored, and highest number in binary 1111, 1111. Hexadecimal it becomes F and F, FFH. Okay, if you want to write it in binary also, it becomes 11111111. Anyways, not required, only decimal also we can solve. Now there is a loop, DCRL. Now DCR means decrement the contents of L by 1. Then J and Z. Now see what is going to happen. L is loaded with 255. Okay, now when you decrement, it becomes 254. Decrement by 1. Jump on non-zero to loop. If the result is non-zero, what is J and Z? Jump if non-zero. Okay, so if the result is non-zero, jump to loop. So yes, whether the result is non-zero, yes, result is 254. So jump to non-zero. Yes, jump to loop. Okay, so jump here. Okay, now jump here means again decrement the content. So that is how loop will be created. Again decrement by 1. So then it becomes 253. Okay, then again, is the result non-zero? Yes, 253 is also non-zero. So again go here. That means again decrement. So that means this loop itself will keep running how many times? Till the result is 0. So you started with the number 255. You started with the number 255. How many times, okay, you want to run the loop so that it becomes 0? It is decremented by 1 at a time. So 255, 54, 53. For 255 to become 0, you need 255 times only. Na? Okay, so this inner loop will run 255 times. Okay, this inner loop will run 250 times. After 255 times, the result will become 0. And if the result is 0, it will not jump. Jump only if non-zero. So now it comes here. Okay, if it doesn't jump, it goes to the next expression, the next instruction, that is DCRH. Now decrement H. What was H? 255. Decrement 254. Okay, but after decrementing H by 1, where do I go? Again here only. So again the L cycle will repeat. But remember, okay, so how many times this loop? See, how many times DCR instruction will be executed? Already I executed this instruction 255 times. Already it was done. 255 plus, okay, then I went to DCRH, okay, I decremented the H by 1, 254. Is it non-zero? Yes, so jump, J and Z again, jump if non-zero. I'll again jump, but where? Here. Okay, so again DCRL. But when I came out of this loop, I will come when L became 0. So now when you are going to the loop, once again L is 0. Okay, L is 0. Now what is 0 minus 1? Understand? But in 2's complement form, okay, see, 0 minus 1 is 0 only. Okay. Okay, if you left it at 0, you are going to decrement by 1. So 0 minus 1, as I am telling you, is minus 1. Okay, is minus 1. But remember, you have to represent negative numbers in the 2's complement form or 16's complement form. Okay, or 16's complement form. Okay, so what is going to be the 2's complement representation of this? Okay, so when you refresh, you will again go back to 255. Now see, the cycle runs like this: 0 to 255, then 0 to 255. Okay, cycle runs like this: 0. I'll better explain. Like the 0 to 255, then 0 to 255. Okay, 255 plus 1 is 0, because the point is you don't have the 9th bit. Okay, it's easy, it's important to line like this. Okay, 255 means FF, na? Okay, or yeah, FF. Let's learn like this: FF plus 1. Okay, now what is FF plus 1? Or better, I'll explain you in binary. More better, the clear, because machine actually have the binary calculation. Okay, 1, 1, 1, 1, 1, 1, 1, 1. So see, if you add 1, what happens? 1 plus 1, 0 carry 1. 1 plus 1, 0 carry 1. 1 plus 1, 0 carry 1. 1 plus 1 is again 0 carry 1. 1 plus 1, 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 0 carry 1. This 9th bit cannot be stored because machine 8085 is a 8-bit machine. So what it is going to store? 0, 0, 0, 0, 0, 0, 0, 0. Now what is this actually? This is 255. Okay, so 255 plus 1 will not be 256, will be 0 actually, because there is no facility to store the 9th bit. Okay, so it will restart at 0. So that's why after 255, 0, or if I'm asking you to go reverse, decrement by 1, so 0 minus 1. Okay, reverse if you go 255. So dear, you now come back to the same point. Second time when you enter the loop, you are coming with the value 0. Okay, we are coming to the value 0. DCRL, when you are coming to the second time, you are coming with L equal to 0. Okay, now when you decrement it, okay, now when you decrement it, it becomes 255. Then you decrement again, it becomes 254. Now how many cycles you need? Okay, you need one extra cycle. From 255 to 0, 255 cycle, but one cycle to make it from 0 to 255. That means total of 256 cycles this time. 256 cycle. Okay, after 256 cycle, again you come to the H loop. Okay, what was the value in H? 255. Okay, so how many times this loop will run? Again 255 times. From H 255, you have to make it 0. That again will run 255. But for the first time, I'll write it like this. For the first time, the DCRL run 255 times. For the remaining 254 times. Okay, this particular H loop will run 255 times, out of which the first time DCRL 255. So next 254 times DCRL, which DCRL will run 256 times. Okay, calculate and write down the item. Okay. So I'll write this way. I'll write down the comment for you. DCRH, this will run, okay, DCRH H loop, okay, it is going to run 255 times. Okay, for the first time DCRL, for the first time DCRL will run 255 times. Okay, and then from next time onwards, the DCRL will run 256 times. That is what, 256 into 254 plus 255. Okay, so how much is this value going to be? Okay, let me just quickly calculate and write down the answer. It is 256 into 254 plus 2, 65279. 65279. Option number A. Option number D. Correct? Option number D. Correct only. Yeah. Okay, done. That's how it is. So as I told you in the beginning itself, okay, 25 questions. There's 25. Okay, few questions from microprocessor, few from mathematics, and of course in the beginning controls and signals were discussed. Okay, hope you have been able to solve, and if you didn't get, you are able to check the answer, able to check the solution. So guys, important point is, again I repeat many a times I told you, ISRO examination is an examination, of course, of your concepts and practice test, but more of a time management. Limited time, more question. Okay, so whenever you are solving the paper in the exam hall, remember that always first solve the question which you are able to solve, either very directly, you tick mark, or otherwise it takes few seconds. Any question which is going to take time, like this question, of course, it is a good question. You can solve it. There's nothing difficult here. Okay, but takes little bit time. Little analysis is there. Okay, try it at the end. Okay, of course, you might see that, okay, it is solvable, but it will take time. You mark it there, no? That it is in your domain, it is in your range, you can solve it, but you will take time, so you'll solve it later. There will be some questions, okay, this topic I have not studied. Cross, okay, that is not in your domain. Some questions which you have studied, but is going to take time, you can, put it for review. Okay, but some questions which are very direct, just tick mark or taking few seconds or up to a minute or so, okay, you solve it first. Okay, don't take any question on your ego. This is my favorite and I'm going to solve it whatever time it takes. No. Okay, solve as many questions as possible first, and then in the next cycle you start solving the other questions which you think were solvable but would have taken time. Also remember, okay, the individual cutoff. You have to score minimum 50% in the technical as well as 50% in aptitude. Don't miss that point. Don't only spend more time on one area. Okay, even if you score full on technical, okay, the full of course maybe still difficult, but out of 80, suppose you are able to go up to 70, 71 in technical, it may be possible. Sometimes technical is very easy, but time is not left and you miss aptitude, you are not qualified. 70, 71 is very good in technical, but still you are not qualified. 50% in both. Okay, so at the same time, aptitude also, some questions are time taking. You see the previous paper as well, I have discussed on YouTube as well. Okay, so it's not like, you first target 20 out of 20. It's good to target aptitude. 20 on 20 is 100% possible, but at the cost of some time. It's not that you spend 1 hour only on aptitude and remaining 1 hour you are solving 80 questions and you are not able to attempt 40 questions. You will not qualify. Remember that. Okay, so that's it, guys. Thank you so much. Yeah, important updates that, yes guys, the new live course, okay, for the Telangana and APAE examinations, Genco, Transco, Discoms, because notifications and good number of vacancies are expected. Okay, so the next online live course starts October 26th. The duration of the course is 5 to 6 months, but the validity is 1 year. That means the syllabus completes in 5 to 6 months, but you can watch the video, all the videos up to the tenure of 1 year. Okay, the fee is 24,999 currently, and for any of the old student, like you have taken whether offline or online any course earlier, you get a 30% discount. Okay, for any more details, you can visit our website or contact our support numbers, that is 95156 and for gate 26 or 27 online course are available. Okay, for gate 26 the online course fee for 1 year 99.99, and for 2 years gate 27 the fee is 28,999. Okay, of course for gate 27 we shall also be coming up with offline course as we always do. Okay, as we always do. No more offline batches, of course, for gate 26, because time is not much left for gate 26. Okay, that's it. I'll share the PDF of this one in the Telegram. Okay, the link is mentioned here. Thank you. Stay connected with the Om Institute channel so as to get more practice sessions and more sessions helpful for GATE, AE, ISRO and all other preparations. Okay, thank you. Stay safe and take care of yourself.